Hi, I'm Sophie Mather, Material Futurist at Biovation. Today I'm going to talk to you about biodegradability, the enablers or enemy within circularity. Before I start though, I just wanted to touch on how this comes up in my work life in a couple of different areas. Firstly, I supported the Textile Exchange for many years as we got the biosynthetics working group off the ground. And one of the big misconceptions that kept coming forwards during that work is people were assuming all the time that biopolymers were automatically biodegradable, which is not always the case. The second area that kind of touches on this is current work of mine at the moment, where I'm a founder and director at the Microfiber Consortium, and we'll have a panel later on today talking about fiber fragmentation from textiles. And again, one of the key misconceptions that comes forward as people start to look at technologies to solve this issue is that if we make synthetic textiles out of biodegradable materials, we obviously don't have an issue because they're safe once they get to land or sea. So again, something else we'll talk on a little bit later. Before I get started though, I had put together my presentation, ready to record it for today's session, and then went off on holiday for a week, where I was very lucky to be spending time out on the English coastal path at a time of year that is particularly beautiful. Leaves are falling off the trees, as you can see here, all the bracken is turning brown, it's breaking, it's starting to go back to nature. And I really felt as I was walking that I was really lucky to be part of biodegradation in action and at its best. You know, every time I walked over muddy paths, I was seeing elements of this bracken that had been broken down, that were naturally going back to nature. And it was really beautiful to kind of see this really happening. And then every now and again, I got a wake-up call because, you know, a bright piece of plastic would come into the path or come onto the beach as I was crossing beaches, just really making me realise that there are a lot of materials in potentially the wrong places, and they're not able to break down or biodegrade as we see nature happening here. So it really got me thinking about the presentation, and I kind of wanted to start with a couple of areas to think about as we go through today. One is the theoretical approach versus the reality. You know, I was very much living in the reality. This felt real to me. And we can look at a lot of academic papers, we can look at a lot of test methodology, but sometimes we need to go back to what is really happening out there. And the other one, which is connected to that, is intentional versus unintentional. You know, the bracken as it breaks down here, intentionally it's breaking down in an area that it was intended to. A lot of the materials that we're using today, and especially ones that we use in the material and textile industry, you know, they are travelling great distances and ending up in areas that perhaps they're not intended to be in. So just have a think about those as we go through today. Also, as I make this presentation, I'd like to think that a lot of what I'm delivering is kind of thought starters, areas to kind of get questions and dialogue going further. I would hope in the audience today that we've got a lot of really expert brains from a lot of different disciplines, different industries maybe, and I think coming together in these sorts of forums will enable us to progress the topic even further. Okay, so let's just start with a couple of very simple definitions linking back to the title. So talking about biodegradable and circularity, biodegradable is the third part in a process. So before we get to this stage, we already have to go through two previous stages. The first being disintegration, so where mechanical action is actually physically breaking down the material ready for its next phase of degradation, which is the chemical breakdown of the polymer chains, and then moving on to the third part, which is the biodegradation. And again, another chemical action where microorganisms break down the materials further into carbon dioxide, methane and biomass, and this is also known as mineralization, which you can see there in brackets. And interesting to see here, or to know here, is that different microorganisms are used or are targeted at different material types. So again, if materials end up in areas that they're not intended to, there might not be the microorganisms there to actually break down the material as you'd want it to. I'm also going to go on to the fourth part, which is compostable, and this is a stage further. And if you look at the ASTM method D883, what they talk about here is that for a material to be biodegradable, it needs to leave no visible, distinguishable or toxic residue. So I think if we link back to the title, enabler or enemy of circularity, I think this is a key part in it, what is actually left at the end. To that point, I want to bring up a 2020 paper by Lycra. It was the 2020 position on biodegradable and compostable fibres, where they talk about compostable items giving back to the soil and enhancing its overall health, while biodegradable items return to the earth but do not necessarily add anything of value. And I think this is really important as we turn on to the circularity definition in a minute, but I'll just finish with this. It also goes on to say that cellulosic-based fibres like cotton and lyocell will biodegrade in the right conditions, but with varying degrees of nutrient value restored to the soil. So I think these are key things to keep to mind as we turn to the definition on circularity, where if we take the Ellen MacArthur Foundation definition here, being the process of designing out waste and pollution, keeping products and materials in use, and regenerating natural systems. So I think it's really important that we look at all of these together and see what from here enables this to actually happen. So back to my walk, biodegradation was happening naturally around me. As I said, as I was walking on the bracken, it was falling onto the path, the leaves were falling onto the path, I was breaking them down as I walked over them. But also very sadly, as I crossed beaches, I was seeing a lot of plastic waste being washed up, which is no surprise to anybody. A lot of these areas here, like the blue and the green especially, there was obviously something that had broken down quite aggressively on the beach, and I was seeing the same colours, the same materials come up many, many times. These weren't, I would imagine, made out of biodegradable plastics, but just a wake-up call here that maybe things were in the wrong places. So I want to move on to a quick animation, and as we go through this, you'll notice that I've placed design or designers in the centre of it. And I think it's really important to look at this situation, this full kind of circular mechanism, which it is, and we need to enable each part of the puzzle to be very much interconnected and thought through with regards to the other stages. And after the animation, I'll go into a little bit more detail in each of the areas, each of the 5 areas. So we start with the raw materials in 3 areas: renewable, recycled and finite. Then we look at the different processes, whether those are new or drop-in. In the product development, looking at the influence of different materials and garment production. And then in the final end of use stages, looking at dispose, composting and recycling. So with that, I'm going to move on to design. So as you can see, design is a very integral part in the central mechanism of this circular diagram. I've put raw materials here to the left because it always seems logical for a designer to start with choosing the right raw materials. But I think it's also questionable whether we really need to start with the end of use options. If the designer is designing something to be biodegradable or compostable, I think it's really important that they start here and work their way back through the process to actually define what that raw material, what that process and what that product actually looks like. So really important part of the process here is defining where that decision making starts. We move on to raw materials, which is perhaps the largest segment here that I'm going to talk about today. As I said before, I've broken this into finite, recycled and renewable. I am going to use a couple of examples as I go through today, but I'm not in any way endorsing them. I'm just bringing them up as examples. So if anybody's wanting to take these further, you'll require your own research behind them, before you adopt them. So the first one, I just wanted to share with you the Cyclo additive technology, which is used on both polyester and polyamide. It's added during the extrusion period, extrusion process as an additive. And what that additive actually does is it creates millions of biodegradable spots on that matrix of the plastic to enable it to break down more readily once it gets into its intended end of use stream. So from conversations that I've had with Cyclo, they are using a marine biodegradation test to ensure the suitability of this technology. And at the end of the presentation today, we'll touch on testing. But I think it's really interesting to see that although people assume that oil-based synthetics don't biodegrade, we are starting to see technologies coming through that will enable that to happen. If we move on to recycled, again, bringing forward an example here, clean impact technology is utilised on polyester, and it's utilised in the carpet industry. And this is where a recycled polyester has a biocatalyst added during the yarn extrusion process as well. And this allows for microbes that are found generally in landfill to digest the material to the same rate of that as a natural material. So again, you know, what is interesting here is this technology is very much focused on it's intending its end of use to be in a landfill, so therefore it's utilising the microbes that you would find in that situation. Whereas the first one obviously intends its product to end up in a marine environment. And then lastly, on the renewable area here, we've seen in the last 10+ years an increased use of renewables, especially kind of synthetic-based renewables. And what we mean here by renewables is that a material is derived from annually renewable natural resources. And I think annually renewable is a really important part of this. So traditionally, it would be things like cotton, wool, silk that we all know and understand very well. But when we look at here at the various feedstocks that are going in, we're starting to see a whole array of new materials, feedstocks going in, such as sugar, corn, beet, bacteria, fungi, algae, etc. So a lot of really exciting feedstocks that wouldn't necessarily have the same impact that we would have from a traditional natural-based fibre. When we start looking at all these new various feedstocks, they all come with various pros and cons, and you can start to see how some of them I've listed out here. Obviously, we've already said that they are annually renewable. If they're plant-based, they're producing oxygen in the production stage or the growing stage. But also some questions that are yet to be answered is, you know, what is the impact of using genetically modified organisms? What is the impact in regard to land use on the food versus fuel debate, etc. So yeah, lots of different areas to take into consideration when you're looking at raw materials. Some misconceptions that are often brought up here, finite materials. People often say that oil-based materials are not biodegradable, but as we've seen in the previous example, we know that some of them are. And also we see that some recycled products are also now biodegradable, where again people were assuming before that they weren't necessarily. And then if we flip that over, renewable synthetics, not all bio-based synthetics are biodegradable. And then renewable naturals, not all natural-based products are biodegradable. And again, we will see that as we come into some examples later on in the presentation. So if we talk very quickly about the processing, this is a very complex intricate area, and it's not one that I'm going to go into a huge amount of detail about. I'm not expert to talk in depth about this, but what I do want to say is there is a difference when you're starting to look at a lot of the new feedstocks and new materials coming through here. We're not just seeing existing drop-in technologies or processing being used. We're seeing new technologies, new processing operations needing to be set up to support the complexities and the opportunities within these new raw materials. And with that becomes, yes, some performance benefits, but also the cost and the time involved in putting together these new process facilities is quite considerable. So just something to bear in mind here, but also it's the marrying together of the raw material and how it's processing that will affect what end of use options are going to be possible at the end of the process. So if we move back to that role of the designer, a very important part, and if there's only one thing you get from today's presentation, it's understanding the influence the designer can have here. Once we get to the product development stage, the designer will choose the material, how that material is put together, the coloration methods, etc., and then how the garment is ultimately designed and put together. So if we start with the materials, we're starting to see more and more blends, both intimate blends and blended compositions coming forward in material constructions. And we know from, you know, circularity conversations and work that the mixed compositions make it far more complex to actually separate end of use. And then if we move on to the coloration and the finishing, there's a whole array of different chemistries and finishes that are applied to textiles to enable them fit for use to us as consumers. and the impact of those or that chemistry can affect and prohibit quite often the biodegradation of a material. I do actually want to bring up 3 examples, 3 papers that I've been looking at recently. One was from 2018 from Chances Vidal, and it was titled "The Imprint of Microfibers in Southern European Deep Seas." In this paper, they looked at fiber samples from the deep sea floor. Only 12.9% of fibers found were to be synthetic. And then in a similar paper in 2020 by Surya, called "Microfibers in Oceanic Surface Waters, a Global Characterization," a very similar study where only 8.2% of oceanic fibers were synthetic, with the most being cellulosic at 79.5%. So you can start to see that the biodegradation that we would expect in those deep sea environments is not necessarily happening. And in the second paper, it goes on to say that a waistcoat was recovered from a deep ocean shipwreck, and it showed almost no signs of degradation after 133 years undersea. So I think the only thing that could really explain why these fibers aren't breaking down is the impact of chemistry and textile finishes onto the materials. And then there's a final one from Ag Research in 2020, "Microfiber Pollution in the Marine Biodegradation of Wool," which looked at both treated and untreated machine washable wool. So you can see how important it is, the kind of selection of different material types. And then moving on to the garments, the material is the largest component when you're looking at garment makeup, but also you've got to consider the sewing yarn, the sewing threads, the labels, embellishments, trims, etc. And it's really important to incorporate all of that into the design of the product if you do want that product to be biodegradable. And then finally, moving into end of use. Here on the recycling side, the big question here is, does biodegradable product help or hinder the recycling process? What we don't want to do is contaminate a recycling process with the wrong waste streams, and if the infrastructure is not there to actually separate and identify, then that could potentially become a problem. I've actually spoken here about compost rather than biodegradation, because if we go back to enabling circularity and go back to the Lycra positioning paper where they talk about compostable items giving back to the soil and enhancing its overall health, I feel that this section here needs to talk about the ability for the material to compost. So finally, just to finish, we spoke before about intended and unintentional use of materials, or kind of fate of where they end up. You can see here on the page that we've got 5 different areas of where test methodologies are showing up. So test methodology for biodegradation in wastewater treatment plants, in compost, landfills, soil and aquatic situations. So as people are testing, they're obviously intending their fibres or materials to end up in any one of these 5 areas. And I think, you know, you can see here from the number of different test methods, and the one in red, just to say that these have been withdrawn and there's no replacements yet. So that the huge number, but we can't test all of them. So if your plastic is only intended to end up in landfill, but it actually ends up in an aquatic situation, has it been tested for the right things? So again, this goes back to what I said at the beginning: reality, or you know, kind of theoretical. And we can conduct a lot of tests, but I think we have to get back to really understanding, you know, the bigger picture here, and the environmental impact if things end up in the wrong areas. So to finish with, finally, I want to come back to a picture that I took on the beach. Again, sorry about all these holiday references, but this really came home quite hard to me. I came across this rubber band in a figure of 8. So obviously the 8 signifies circularity, but for me, this was as far from within that biodegradation or circular kind of system as we could possibly get it. You know, it's a rubber band, so it's not able to be recycled or composted in any sort of way. So just a little reminder really to us all as we finish up today's presentation. So thank you for your time. I think we've got some time now for questions. And if you've got any further questions, please reach out and you can contact me through these contacts here. Thank you very much.